Hello, this time I will discuss theorems involving angles, arcs, and chords. Theorem number 1 states that the measure of a central angle equals the measure of an arc it intercepts. So let me draw a central angle. So this is the middle or the center of the circle. Let's say this is the central angle. It says here that the central angle, so this is the angle, equals the measure of an arc it intercepts. So the arc it intercepts is this one, of course. So if this angle measures 40 degrees, then the measure of an arc it intercepts is also 40 degrees. So equal measure. Theorem number 2, the measure of an inscribed angle equals half the measure of an arc it intercepts. Let me draw an inscribed angle here. So this is an inscribed angle. It says here the measure of inscribed angle equals half the measure of an arc it intercepts. Let's say the measure of this inscribed angle is 40 degrees. Then if it is half of the arc it intercepts, this is the arc that it intercepts, then simply multiply 40 by 2 for us to get the measure of the intercepted arc. So this is the illustration and explanation of this theorem. Theorem number 3, inscribed angles intercepting the same arc are congruent. So here, there should be two inscribed angles. Let me draw two inscribed angles. So let's have first the yellow inscribed angle, this one. And then another angle, let me change the color of my pen to green. And then let's say this is the vertex of the green angle. It says here intercepting the same arc. So if this is the arc of the first inscribed angle, then my second inscribed angle should have the same arc also. So I have to connect this to my inscribed angle, which is green. So I have now two inscribed angles, the yellow inscribed angle and the green inscribed angle, and they share the same arc, this one. So according to the theorem, inscribed angles intercepting the same arc are congruent. So meaning to say, these two angles are equal. So if this is 20 degrees, then the green angle is also 20 degrees. And of course, the intercepted arc equals 40 degrees. Simply multiply one inscribed angle by 2 to get the measure of the intercepted arc. So that's the meaning of this theorem. Theorem number 4. In a circle, an inscribed angle that intercepts a semicircle is a right angle. Let me draw first the diameter for me to have a semicircle. So here, we have now a semicircle here. And then what else do I need to draw? An inscribed angle that intercepts a semicircle. So let's have an inscribed angle. Let me change the color to red. So this is the inscribed angle, the red one. This angle is inscribed because the vertex is here on the circle and it intercepts the semicircle. So this is the semicircle that the inscribed angle intercepts. What does it mean? If the inscribed angle intercepts a semicircle, then it is a right angle. So this red angle is a right angle. So we can draw here a square corner, meaning to say the measure of this is 90 degrees. So don't forget that the measure of a right angle is 90 degrees. So don't forget that. As long as the inscribed angle intercepts a semicircle, which is this one, then the measure of this angle is right angle or 90 degrees. So that's the meaning of theorem number 4. Theorem number 5, congruent chords of a circle are equidistant from the center of the circle. So here I should have two chords, congruent chords. Let's say this is my chord number 1, and my next chord should be congruent to this. So meaning the same length as that. So this one is another chord. So let us assume that the two chords are congruent. So meaning to say they are equal in length. So according to the theorem, as long as the two chords are congruent, then they are equidistant from the center of the circle. So meaning to say, what do you mean by equidistant? The same distance from the center. So let's say this is the center. If you will measure the distance from the chord to the center, the distance is this one, this line or this segment. And from the center to another chord, it's also the distance of this chord from the center. So it says here that as long as the two chords, the two yellow segments, are congruent or equal, then they are equidistant from the center of the circle. If you will measure these two segments, then they are also equal. So if the length of this line or of this segment is 5, then the other segment from the center to the chord is also 5. As long as the two chords are equal. Let's say the two chords are 6. So 6. So without actually drawing 5 and 5 here, understood that they are equal or congruent. Theorem number 6, opposite angles of a quadrilateral inscribed in a circle are supplementary. Opposite, quadrilateral, inscribed, supplementary. So these are the important terms here. Let me draw an inscribed quadrilateral. When we say quadrilateral, any figure with 4 sides, whether rectangle, square, rhombus, parallelogram, and other figures having 4 sides. So let's say this is my inscribed quadrilateral. I have 4 sides now. And to make it really inscribed, see to it that all the vertices are touching the circle, are on the circle. Let's say if you have this figure, circle, and you have a square inside, this square is not inscribed because the vertices are not on the circle. So to be inscribed, all the vertices should be on the circle. Next, opposite angles of the quadrilateral are supplementary. So what are opposite angles here? Let's say angle A is opposite to this angle. Let's say angle B. What else? Angle C is opposite to angle D. According to the theorem, if you will add opposite angles, then they are supplementary. Or opposite angles are supplementary. So let's say angle A plus angle B, the sum should be 180 degrees. So to be supplementary, the sum of the angles is supplementary. And another is angle C plus angle D. The sum is also 180 degrees. So let's say, let us assume that angle A is 40 degrees. Then what is the measure of angle B? Simply subtract angle B, the measure of angle B is 180 minus 40 is 140 degrees. Because the sum is 180 degrees, if you know the other angles, simply subtract from 180 degrees for you to know the missing angles. That's all about Theorem 6. Theorem number 7, in a circle, if the diameter is perpendicular to a chord, then it divides the chord into 2 equal segments. Let me first draw a diameter. So this is my diameter. And this diameter should be perpendicular to a chord. Let me draw a chord also. that chord or this chord should be perpendicular to my diameter. So I have now two perpendicular lines, the chord and the diameter. So they are perpendicular, meaning to be perpendicular, just a review or a recall, they form a square corner here. All the corners are square. Meaning to say, the measure of each corner is 90 degrees. Now, if the diameter divides the chord into two equal segments, we can say that this length, this first length, this one, is equal to the half length. So if this length is equal to 4 units, then the half length is also 4 units. So that's the definition or the illustration of this theorem. I hope this is clear and you understood the illustration.